I welcome everybody for the fifth EVOKE session by EV Committee, Southern Indian Chamber of Commerce and Industry. And for the new attendees, what is EVOKE? It represents an electric vehicle open knowledge for everyone with an aim of bringing an awareness of latest happenings and innovations in automotive industry to both industry and academia folks. In our last session, we covered about fuel cell technology and its trends from electrical segment. As we all know, propulsion or the powertrain system is not the only area where the transformation is happening. The automotive industry is experiencing a 360-degree shift in autonomous, connected, as well as shared mobility sectors as well. With the latest advancements in advanced driver assistance system and autonomous car technologies, cars are becoming more intelligent in its decision-making capabilities, prioritizing the safety as well as pedestrians. Yes, today's topic of discussion is about the latest trends in technologies and hardwares for enabling advanced driver assistance system and autonomous driving. And I am Sri Kalevani, the Education Director at EV Committee SICI, with a strong goal of bridging the gap between industry and academia. And I welcome Mr. Henry Joshua, Chair of EV Committee SICI, and also Head of Business Development, Battery Intelligence and Wireless BMS Analog Devices. With over 20 years of automotive and semiconductor experience, Mr. Henry believes mobility is an expression of sense of freedom, and sustainable mobility is the need of the hour for Mother Earth. Though located in Germany over 15 years, living in the USA, his heart has always been with India, and he has deep passion in sharing his global experience and empowering next generation young minds like us and professionals. I also welcome our esteemed speaker today, Smita Vikas, an alumni of IIT Bombay, brings over 1.5 decades of experience to ADAS system filled with automotive industry. Her notable achievements include 8 publications and 3 patent applications in this domain, specializing in software solutions for active safety systems. She focuses on software sensor fusion and AI/ML domain. At Qualcomm, she applies her expertise to lead the ADAS system and the expertise team in optimizing these algorithms with the Snapdragon's hexagon processor. As a personal note, she is an avid reader, passionate traveler, and also serves as a Vedic maths teacher. Now I request Mr. Henry to give a short introduction about today's topic of discussion. Over to you, Henry.
Thank you, Kalai. I don't want to take too much time because I want to give the focus on the topic, but here's the point. ADAS isn't about driverless car alone. The sci-fi films like, Men in Black, they did a great job in helping us focus on the driverless driving part. But do you know there are at least 25 other functions and features that fall under ADAS? Say, for example, even adaptive cruise control, night vision, driver monitoring system, collision warning, lane assist. Yeah, I mean, don't ask me, there isn't even proper lanes marked in Chennai, but how can there be assist? There are, yeah. So there are lane assist functions, emergency driver assistance. So there are multiple features like this, and these are all ADAS as well. Now, behind the screen, there's also the sensors, the data handling, multi-core processors. These are all playing the part behind, right? And not to forget the huge amount of data that's being generated. Vehicles fitted with autonomous driving features, these can actually generate about 4 terabytes to 5 terabytes per day. The cameras in ADAS, I mean, there are multiple sensors. You're going to hear about all of this from Smita today. But let's say cameras, right? This can generate about 20 to 60 MB per second. So this means the data carriers, communication lines, protocols within the car, and along with its corresponding electronics architecture, these all become so important, right? Say, for example, these days, vehicles are transitioning from CAN-based communication to automotive Ethernet. Yeah. So I believe there are many intrigued and energetic students in this call. If you are interested in building your careers related to ADAS, see, the opportunities are not just limited to electronics or AI and software, but you can also imagine and think about roles related to communication protocols, data management, system level testing, and these all become relevant, right? And even data security and data privacy are all important. So when you think of ADAS, there is a lot more to it than just driverless car. Today, you're in for an exciting ride. Enjoy it, and I hope that you're benefiting from this information from Smitha. You're going to get this really good information from someone who is working on it hands-on. So thank you, and then I will hand it over to Smita. Feel free to, if you have any questions or so, you're also welcome to share this using the chat. And this session is for you. It's for your benefit. So yeah, support it and get value from it as well. Kalai, Smita, back to you. Thank you.
Yeah, thanks. Thanks, Kalai. Thank you, Henry. Yeah, thank you all, and really appreciate being in this platform and sharing my knowledge. So just let me know if you can see my screen.
Yes, madam.
Yeah. Yeah, so I'm Smita Vikas, and I'm part of Qualcomm team. I'm an engineer, and I am working as in the ADAS domain. So today's topic of discussion is Beyond the Wheels, about autonomous driving and urban mobility. So first, I'll start with what is urban mobility, and then go into how urban mobility is shaping, and how autonomous driving is taking this forward. Before we start into autonomous driving or urban mobility, first let's look at what's happening in India itself, right? Outlook of the Indian automotive industry. We know that, maybe in few years down the line, India would be ahead of Japan, and it would become the third largest automotive market. So what is driving this trend, or what is making this happen? So according to me, there were three important points. The first was the technology itself. So as we know that our government is pushing towards net zero by 2070. So the government policies, and along with that, our own OEMs, whether it is Tata, Mahindras, they are bringing into the market new technologies. So one is the greener aspect of it, having the electrical vehicles there. And second is the ADAS growth, what is happening, right? So people are looking for both greener as well as safer option. And this is today available in the market. So we have the latest XUVs with ADAS functionalities. If you know, today's Mahindra or Tata would have the basic L1 ADAS functionality. We'll look into it, but this is what the trend or the technology is. The second important factor which is driving is the infrastructure itself. So if you see over the period from 2014 to 2023, there is an almost 59% of increase in the national roads which are on the Indian roads, right? Second is the government is also pushing for the electric infrastructure, right? The EV infrastructure. So along with the EV growth, we need the infrastructure which supports it. So one is technology, second is infrastructure. The third important factor is the human psychology. Hello?
Yes, madam. Go ahead.
So the
Go
third
for it.
important factor is the human psychology itself. Now, if you look at it, people are ready to move in towards the safe options. So almost, if you the recent trend, this is a trend by Deloitte, and they made a study, and almost of the number of people that they interviewed, 52% of the people are ready to move towards safer options. Second thing is, what is interesting is about the shared mobility. So the private ownership, so the people are ready to move from the private ownership to shared mobility ownership. I mean, they are ready to have a shared mobility. So these are, so the change what people are experiencing or they want it is actually driving towards this exponential growth in the India market, right? So with this, I will actually set the trend for today's discussion. So I'll be talking about four topics. One is the future of automotive. Second is autonomous driving. So in the future of automotive, we'll speak about what is shared mobility and what is, so as Kalai and Henry mentioned, what lies today in the or what is there for US students in the automotive sector. Second is about autonomous driving. So here I would speak more about the regulations and what is going behind, how is the testing of autonomous vehicle happening. All those factors I would cover in autonomous driving. Third is ADAS and sensor fusion. In ADAS, so we will go more deeper into what is ADAS. ADAS is actually, the ADAS is advanced driver assistance systems and sensor fusion. So when you have multiple sensors, how are the algorithms evolving? Along with that, how is the hardware evolving, right? And the fourth is about Qualcomm itself. So being a pioneer in the 5G network, being a pioneer in has established itself in the in the mobile domain, how they have been able to move into the automotive domain, and what we are doing in the automotive sector. So these are the four topics that I would cover today. So let's get started. Now, future of automotive. So recently there was a study by McKinsey, and there are two important things that I want to highlight here. So the first thing is, so what they did is they did a study of the dominant mode of transport from 2023 to 2035, right? And two things or two takeaways that I have is, one is in 2035, the percentage of private ownership would be reduced by 15%. So people are ready to not use a personal vehicle, but rather move into shared mobility. So second thing is, there would be an increase in e-mobility services. So e-mobility is more like a micro mobility along with shared mobility. So to understand this, I'll just take the few minutes on what is e-mobility. So when you want to look at e-mobility, so it covers three aspects. One is the micro-mobility, ride-hailing, and ride-sharing services. So I know pretty much most of you would know about what is ride-hailing. So you would have used Ola or Uber, right? Today, if you come to Bangalore, you will have something called as a Blue Smart. It's a complete, the entire fleet is battery operated, and it's much cheaper than Ola or Uber. The second one is ride sharing. So today, if I want to go to office and there are a couple of people who are using the same route, you can use this app, and you can, share the ride with them, right? So this is another option. What is more interesting is micro mobility. This is Yulu bikes. So again, if you come to Bangalore, you see these bikes everywhere. So I just wanted to highlight a recent incident. I think last November, we had a major traffic jam, and most of our colleague, we took around 4 to 5 hours to reach home. But one of our colleague, he got down off the cab. He took 3 bikes to reach home. So what he did is he took first Yulu bike, used it till a particular destination till the charge lasted, and then he used another bike. So he was able to use this bike, Yulu service, to reach his home, and he was able to reach in maybe 1 or 2 hours. So that's it's not that you have to use during traffic jam, but I can give you a typical example where micromobility will be used. Suppose tomorrow somebody of you, a student, can develop an app wherein say I want to reach the airport, right? So what I do is I use your app, and the app is going to, which has the option of say it tells you that I want to reach the airport. I can take a Yulu bike till the metro station, and from the metro station I can use a from this metro station, obviously I can use a metro, and it gives you a scanner code. So you can take the scanner code. It will tell you where the Yulu bike is placed. You can scan it, use a bike, park it at the metro station, and then use the scanner to no, use the metro station, metro service. So what actually happens is this becomes so convenient. So the last mile connectivity is something which we are looking at, this micromobility services. The micromobility can be a bike, it could be a cycle, it could be also a three-wheelers, right? So what a future or the government should plan for a smart ecosystem is they could have these parking stations which are near your no houses or near your locality where there are residential complexes, and then you could have those main metros or the buses which is running on the main highway. So in that way, what happens is there would be less load on the traffic. So this is one of the use cases or one of the applications that I see for micromobility, right? So now all these images that have got us from our India market, but globally, if you see, there is a huge demand for micromobility. By around 2030, this market is going to reach around $440 billion. And similarly, for ride sharing and ride hailing, it would be around $1 trillion market. So there is, as we saw, people are ready to for this change. Also, the technology and the market or the infrastructure is supporting us for this change, right? Now, with this, what would be the new areas or the business models that are going to come up? So it's not that there are not other business models, but I just wanted to highlight two new business models that are going to come up here. One is car as a platform, and second is mobility as a service. So when you look at car as a platform, tomorrow your car is equipped with so many sensors, right? Uh, and these data, what is generated in your car, it could be similar to like a Yulu or a ride hailing or any other platform, where say suppose you have a fleet of car and you want to send out your or you want to understand how the user is or the driver is performing, or you want to know how if there is an issue with the vehicle. All this data is very important for further analysis. It can be also useful for traffic management. So tomorrow you can also charge a royalty for the data that your car is sending out, right? It could become a business model. So these are a couple of applications that we look when as car as a platform. When you look at mobility as a service, your vehicle also needs data from the infrastructure. Like tomorrow, you want to park your vehicle, you need to know where the parking spot is. If you want to charge your vehicle, you need to know where the charging point is. You want to make a payment to the external vendor, or you want to take the payment from the user. All this are the new business or maybe existing, but some of the business models which is going to grow exponentially in the coming years, right? So I hope this is clear. Along with that, what would be the other technology areas that is growing in the automotive segment, right? So one is shared mobility, as we saw. The other four areas which is parallelly growing is one is connectivity. So connectivity, we just saw we need vehicle to vehicle connectivity or vehicle to infrastructure connectivity. So V2X, V2B is, as Shrikalai also mentioned, is one of those areas which is growing. Recently, there was, I mean, in the Times of India, we saw ad which was there was a discussion which was done by Vistion CEO, right, Sachin, where he mentioned something about vehicle to grid infrastructure. So what is happening is today your battery, which is there in the electric vehicle, is getting their energy from the grid. But when your fleet of vehicles is ideal, what would you do? You can power this energy back to the grid, right? So uh, what actually happens is, so your battery is becoming an energy source which is powering the grid. So that is called as power vehicle to grid infrastructure. So along with vehicle to infrastructure, you have vehicle to grid infrastructure connectivity, which is a growing model, right? And people are exploring this area as well. Second thing is autonomous driving. Autonomous driving is like a buzzword. I would say it is an end goal. The most important thing in autonomous driving is safety aspect. So how do you ensure that your vehicle is safe? The safety aspect, entire thing is studied under autonomous driving. The third is electrification. So today you have battery operated vehicle. We are also speaking about hydrogen cells. There are vehicles on the road like Tata Mirai, BMW recently came up with their vehicle. The challenge with today bringing hydrogen cell is the charging stations, which is not available in India. So tomorrow you will have, if these infrastructures are ready, we'll be able to bring in hydrogen cell vehicles as well, right? Apart from these other technology, cybersecurity is the fourth area which is growing, because your car is transmitting data in and out, right? And because of this, cybersecurity is very important, and a lot of work happening in this area. So I took some time on this slide, but these are the four aspect. So it's called as AECS. One is autonomous driving, electrification, connectivity, and shared mobility. So these are the four areas which is growing exponentially, and there's a lot of opportunities in these areas. Okay, so with this, I'll any queries or any questions so far? Okay, let's get started. So autonomous driving. Shrikalai, sorry, you can hear me, right?
Yes, you're audible.
Yeah.
I think we can take a
So when you talk about autonomous driving, as I told you, it is just a buzzword, right? The most crucial thing so it is the end goal. The most important thing is the advanced driver assistance system. How do you ensure that my vehicle is safe? So we have something called as the level of automation, and this was defined by the Society of Automotive Engineers, SAE. So we have 6 levels of automation, starting from level 0 to level 5. We'll be talking more about the first 3 levels of automation, which is level 0, level
Hello?
1, and level 2.
Hello?
Hello? Okay. And autonomous driving is level 3 to level 5. So level 0 automation is that it means that the driver is has full control of the vehicle, whether it is steering, the braking, the acceleration, the driver is in control of your vehicle, right? But doesn't mean that you cannot have certain features. You can have features like lane departure warning. You can have features like forward collision warning. Forward collision warning is if there is an obstacle in front of the vehicle, it will give you a warning saying that there's an obstacle at a distance of so and so meter with moving at so and so speed, right? So this is a warning which the vehicle can give to the driver. This is included in level 0 automation. But the most important thing in level 0 to level 3 is the driver is in control of the vehicle, right? The second thing is level 1 automation, where you have features like the adaptive cruise control and lane keep assist. I'm pretty sure today's vehicle, it says the level 1 automation in Mahindras or Tatas, which has come out, have mentioned about the adaptive cruise control. What is adaptive cruise control? Suppose you have an obstacle in the front, it identifies that obstacle, and if you keep your vehicle in cruise, it can slow down or it can increase its speed based on the obstacles which are present on the vehicle. This is available mostly on the highways, so you can keep it on cruise and not relax your legs. Okay, so that's a basic functionality, but doesn't mean that driver can release the hand over the steering. So if an accident happens, the driver is responsible in the level 0 to level 2 automation. LK lane keep assist is something like it will detect the lane and it will ensure that the vehicle stays within the lane. So that is lane keep assist system. In level 2 automation is the partial automation, where there's a combination of both lateral and longitudinal feature. That means you can have both adaptive cruise control and lane keep assist. So when you're cruising, it will ensure that the vehicle doesn't steer away from your lane. Okay. Now, when it comes to level 3 automation, you can have features like traffic jam assist. That means in the traffic, you can allow the vehicle to monitor the environment and make decisions. So this is called as the traffic jam assist. Second feature, which is very commonly present, is the autobahn chauffeur. So autobahn chauffeur is, suppose that in emergency situation, there the vehicle has to slow down or stop, then the vehicle automatically senses such a situation and will steer the vehicle to the nearby away from the highway and to a safer place. So that is so these kind of features like traffic jam assist or autobahn chauffeur is available today in high-end vehicles. But if you see those, they are not classified as level 3. What as per the SAE norm, the level 3 to level 5 automation does not guarantee that the driver is in control. So what they have done is they have made it as level 2 plus features. So the traffic jam assist or the autobahn chauffeur are claimed as level 2 plus feature and not level 3 feature, because still I mean, it is not completely a driverless feature. It still needs a driver to be present in the situation. Okay, so I hope this is clear. With this, let's understand the regulations which is driving this vehicle or making the vehicle safe. Now, so we are talking about the ADAS functionality, Advanced Driver Assistance Systems. There, you might have heard about ISO 26262 or the functional safety standards. These are the regulations which ensure that your vehicle driving on the road is safe. Now, the functional safety standards, it covers the road vehicles with electrical and electronic systems. It covers the entire development cycle. So there are 10 areas which it covers, right from the use case definition to the hardware, software. So there are different sections demarcated for software, for hardware, for systems, and there's a separate section for ASIL. Now, when you talk about safety, the most important factor is the risk. So you have a smallest system, and what is the risk involved in using that system? That is how they have classified safety. Now, the risk can be computed in two ways. One is, or it can be classified as severity of a failure. In what situation, or I mean, what is the severity of failure? Severity of failure is classified as S1, S2, S3. S3 is life-threatening. That means there is definitely, I mean, the person is going to lose his life. That's the severity of failure. Probability of exposure means in what situation or how often will this risk happen is called the probability of exposure. So based on severity of failure and probability of exposure, risk is classified as severity into probability. So that's how the risk is classified. Now, based on this risk, will the driver or the vehicle be able to control such a situation is the next part. So if he is able to control, that is C1, and C3 means the driver or such situation cannot be handled. So based on severity, probability, and controllability, we have the ASIL levels. ASIL is the automotive safety integrity level, and it has five parts: QM, ASIL A, B, C, and D. QM is quality management. We don't do any safety, uh, or we do not consider the system for safety. Whereas you have ASIL A, B, C, and D, which are different levels of safety. Now, when you look at SLD, you have only one column. When it is severity is very high, the probability or the risk happening often is very high, and it is not controllable. Then only we go for SLD. The reason behind SLD component or designing an SLD is quite expensive. The number of tools, number of efforts that is required is very high. So what we do is, instead of doing an SLD component, right? It's not that the other SLA or SLC is not risk free, but in an SLD, it is decomposed into lower SLs. So you take a complex system, you break it down, and ensure that together it is SLD. That's how the process is done. Now, to give you an example for how do you understand functional safety is, suppose you have a vehicle, you have a emergency parking brake, right? You park your vehicle on a slope, and for some reason this system fails, right? And the vehicle is moving backward. So it is not very severe, the severity is S2, and the rate at which such a system can occur is, say, E3. Assume that it is E3, and we say that it is not, it's not a C3 system but a C2 system. If possible, we can control it. So now I want to develop an ASIL A system. So what will be the use case for such a system? So you have a parking brake, a parking system, which you have placed it on the ramp, and it is moving, or it has failed. So your safety system will the safety goal will be to identify such a system and define a use case which is going to prevent such a occurrence of such a system. So together, the safety system, along with the emergency braking system, is called as a safe system. So the idea of functional safety is to identify such risk or systematic failures which are occurring in your system and create a solution for that. So together, your vehicle is safe, right? Now, the scope for functional safety is only when, or it is only for systematic failures or random hardware failures. It will not cover situations which is an intended function. Say, for example, we recently had a Tesla incident where, when the vehicle was moving in the reverse direction, it fell into a pond, or the person was affected there. Now, actually, if you see, when you put it in the reverse gear, the vehicle had to move behind, right? It is an intended functionality. So functional safety standards, or ISO 26262, will not cover such failures, because it is an intended functionality. There is no failure there. So how will you cover such situations? So there is something called as SOTIF, which is a safety of intended functionality, wherein when you're going to define or you're going to design autonomous vehicles, which involves AI ML, which involves sensor failure. So so the intention of this system is to work in a proper way, but due to some external factors, there are harm. It causes harm to the driver. Then how do you handle such a situation? So there is these regulations which is being studied. It's still in progress, and in this area there will be a lot of work involved. So how do you test such systems, which involves autonomous driving, which involves AI and ML? This is called as SOTIF. I've not put it here, but because it is still under development phase, right? So I hope that is clear. Now, the second important thing is so ISO 26262 is the responsibility of tier ones, the responsibility of OEMs to ensure that your vehicle or your algorithm that is written is safe and it comes out to the market. Now, once that is in the market, how do you ensure that or how do I ensure that the vehicle is safe? So there has to be a third party who assesses these vehicles which is coming out in the market. And that, if you see today, you have the Bharat NCAP, you have global NCAPs. This is, I have added here is the Euro NCAP, which is an European new car assessment program. So what do they do is the aim of any NCAP is to ensure the cars which are coming out in the market are safe to drive. They have, if you open an NCAP document, they have various tests related to whether it is airbag system, whether it is a pedestrian detection system, whether it is ACC system or a cruise control system or a lane departure. So they have multiple tests, and if basically they give you ratings. So if you want to purchase a car, it will say that global NCAP rating is say 5-star. So when it is a 5-star rating, you know that they have tested on so many various factors, and it is safe to use on the road. They do not define the legislation, but they improve the regulation. So it is not a government body. They work with the government to do this assessment, right? So in India, we have Bharat and CAPS. If you look at the Vision 2030, what I want to highlight here is we already have commercial vehicle, passenger vehicle, two-powered vehicle. Tomorrow, what they are planning to introduce is safety for shared and autonomous vehicle. So along with the demand or the change in the industry, there is already regulations which are coming for testing the shared and autonomous mobility. Along with that, as we were talking, we also have a separate section for vehicle security and access to data. So these last two sections have been recently added. The earlier ones were already present. Okay, so this is about the regulations and how the vehicle which is on the road is being tested. Sorry. Okay. Now coming to ADAS and sensor fusion. So we looked into what are the market trends. We looked into the autonomous driving, what are the regulations, and how these vehicles have been tested on the road. Now, when you look at ADAS and sensor fusion, what is the how the algorithms are running in the ADAS domain? That's what we are going to look here. Now, if you look at ADAS or the advanced driver assistance systems, the most important factor are the sensors. Sensors are the vital for vehicle perception and localization. Now, there are today, a vehicle has close to 100 plus sensors, and this is going to increase to around 200 plus sensors. So the amount of data a vehicle is getting is enormous. That's what even Henry was mentioning, right? So how do these sensors around the vehicle sense and make information out of it, or how is information derived out of it? Most of these sensors are either camera, radar, or ultrasound sensors. Now, each of these sensors has their own limitations. Like a radar sensor is very good at long range. So you have sensors like radar, which works as adaptive cruise control, emergency brake assist, for pedestrian detection, collision avoidance. You can use radar or lidar. When it comes, so the range of a radar would be around 200 to 250 meters. When it comes to camera, you don't have a very large longitudinal range, but laterally it covers a larger range. And with regards to object classification, they are too good. Okay, so traffic sign recognition or a lane departure warning, you cannot replace a camera for such systems. Even driver monitoring system, you would need a camera does a good job in monitoring the driver facial expressions. So these sensors, each of them has their own pluses and minuses, and you cannot remove one of these sensors. So what is the best thing to do is to combine the information about both these sensors. So if you see today's systems or going forward, you will have a combination of radar and camera, radar and lidar, or I'm sorry, or lidar and a camera, or together all these systems together as a fusion system. Okay, so currently you will find standalone cameras or radars in most of the systems, but going forward, a fusion system is what is going to make the environment or more the information from the environment will be more accurate if you're going to use a combination of these sensors. Okay, now most important thing is about lidar. Today the lidars are very expensive. Using a lidar in the vehicle only you would find in top end vehicles, but going forward there's a lot of work happening in this area. The precision, the 3D precision, or the object accurately defining the lidar position, the position of an object is very good with lidar. So if you want to achieve level 5 autonomy, lidar is the most significant sensor that would be available in the future vehicles, right? So this is about sensors. Now let's understand the evolution of algorithms in the with sensor fusion. If you see today, the amount of volume of data that is present in in a vehicle is around 5,000 terabyte of per vehicle per year. So the amount or the volume of data that is available in the vehicle is huge, right? So with this high volume of data, the algorithms are also evolving. So earlier we had a standard machine learning algorithm because we had one sensors or two sensors. Today we are talking about Gen AI and deep learning networks, which they feed on data. So if you have more data, you can easily switch to deep learning or a Gen AI kind of a network, right? So how does the sensor fusion work? Now, if I have to say sensor fusion, sensor fusion can be classified as three different algorithms. One is high level fusion, medium level fusion, and low level fusion. When you talk about high level fusion, suppose I have a camera and I have a radar. The camera says that there is an obstacle in the front, and the radar is also saying that there is an obstacle, right? But since the frame rate of a camera is higher, that means per second the camera can generate more frames or more information. I rely more on camera, right? With camera probability as higher and the radar probability lower, I combine this information and then make a decision. So that is called as a decision at the decision level or the high level fusion. In medium level fusion, what happens is today I have a lot of data or have a capability to process it. I take the camera information, I clean it up, I take the radar information, clean it up, and combine, extract features out of them, and then use machine learning algorithm to learn this, right? So that is called as the medium level fusion. In low level fusion, I don't do any cleaning. I take the raw information from the camera, raw information from radar or any other sensor, use both these features to use a deep learning network to combine them or to make information out of it. So that is low level fusion. So decision level fusion, we'll keep it aside. We'll try to understand the difference between medium and low level fusion. In low level fusion, the challenge is the volume of data, and most of the data, much of the data would be redundant. So removing this data, processing this data when the vehicle is running, it takes a lot of time, right? And it is highly complex. Maybe the accuracy is too high, is too good, but the amount of processing time or the processing volume of data is too high. The other challenge between in medium level fusion and low level fusion is the sensor calibration. Now, imagine you have a camera. The camera is fitted behind the dashboard. It is looking forward, whereas a radar sensor is on the bumper. So both of them has a different coordinate system. right? And both of them are looking on the road. So if a camera is saying there's an obstacle and the radar is saying no, there's no obstacle, that means they have to talk to each other. So talking to each other is called as a sensor calibration. They both should be looking at on the same object at the same coordinate space, right? So that is called as sensor calibration. And this is a most important thing when you come to sensor fusion. So calibrating and ensuring that these coordinates match during runtime, any failure in that is going to change or make your entire algorithm go for a toss. So the most important thing in medium level or low level fusion is the calibration of the sensors. Okay. So sensor fusion is going to become a prerequisite for future vehicles, and with the deep neural networks or Gen AI algorithms, they will excel both at future extraction and classification. So this is an overview of what is happening in sensor fusion. I'll go a little more, I mean, a simple example of high level fusion, what exactly is happening before I go ahead. So Kalman filter is a very common algorithm which is used for sensor fusion. I'll just give you a typical example. Suppose this is a vehicle which is at 80 kph and there is an oncoming vehicle which is coming at 20 kph, right? Now at suppose this is a radar data. This is how you see. This is a simulated data where you have a lot of scatters around, and this object is say at 170 meters. Okay, so now this object, to give you know what actually happens at 170 meter, the time to collision to this object is around 6 seconds. So at 170 meters, I have only 6 seconds of window to process my entire data, right? So now my camera, my radar need to fetch me this information. Suppose tomorrow you have an autonomous car, right? So it has to fetch this information. You have to make sense of this information and then provide it back to the driver or to the vehicle accordingly, right? So the window that I have is only 6 seconds. So how does this happen? So if I look at the algorithm, this is a very simple algorithm. You have a camera data and a radar data, which is at an interval of, so the camera frame rate is 30 milliseconds. Today you have better cameras. I'm just giving you an example of 30 milliseconds. So every 30 millisecond, you have the camera data coming. And every 60 millisecond, the frame rate of a camera is higher than the radar. So every 60 millisecond, you have a radar data, right? What what will I do intermediately, or what can I do when these data is not available? I still need to make a prediction, or still need to make an estimation. That is when these algorithms come into play, right? So what does Kalman filter do is it will take these measurements, it will update, and it will make a prediction when you do not have these data available about the position and the velocity, right? And when you get these measurements from the camera or the radar, we have an update state. That means it improves the estimation of the algorithm. Okay, so if you have multiple sensors, the update is going to be much better. Rather relying on one sensor information, if I rely on two sensors, which is going to give me the accurate, the estimation of, or the estimation of the position will be much more accurate. So that is why we use multiple sensors to estimate my environment. I hope that is clear with this. Okay. So multiple sensors enhance the capability to accurately detect the objects in the environment. That's the advantage of sensor fusion. Okay. Now, coming to what is the challenges and the opportunities of sensor fusion? Now, as we know, the amount of data that is coming out from the sensors is around of terabyte of data, right? And this is a typical application layer, or how the algorithms are fitting onto the hardware system. So as we spoke, we have the sensing system, we have the lidar, radar and camera, or the GPS systems. Now with this, you have to make information out of it. So you have your a deep learning network, which is taking this information, localizing it. You will have object recognition, object tracking. All this is software. And then you have your decisions where you predict where your object is, or you can use it for path planning, for obstacle avoidance, or other things, right? So these algorithms, when you're talking about developing algorithms, you develop these algorithms as softwares, but this has to go inside your vehicle. So how does it go inside the vehicle? You have today you have the operating systems, like you have your Android operating system or your Linux operating system, so you can run these softwares on them. But underlying this, you have the hardware systems, right? So you have your, say, your CPUs, your GPUs. All these algorithms should fit into those hardware systems, and there are certain limitations because these are safety critical algorithms. As we just saw, that the time that is there to estimate an object at a particular distance is, say, 6 seconds, right? So within that window, you have to process a lot of information and give out the decision to your vehicle. So earlier, you had these distributed hardware systems like ECUs, which were doing independent processing. But as your intelligence of the vehicle is increasing, these hardware systems, especially the CPUs, would not be sufficient to carry out these processes. So what is evolving in this area? So today we have something called as the heterogeneous computing platform. The heterogeneous computing platform is, you call as SoC, or system on chip, which has multiple processing unit present in them. So you have a CPU, GPU, and DSP together. So one algorithm, what a hardware engineer can do is they can distribute it amongst the CPU, GPU, or DSP. So DSP will be used for the digital signal processing application. The GPU is graphic processing unit. Today you have GPUs doing AI/ML kind of algorithms, and CPU can be used mostly for controlled algorithms, like you want to do a pre-processing or initial cleanup of your image or something. You can use a CPU. So more intensive work, if your algorithms like this, perception or decision making, can be handled by the GPU and DSP, right? So with the heterogeneous computing platform on the vehicle, you would be able to run these high-end algorithms. Otherwise, it is quite challenging, right? So a heterogeneous computing system is basically it combines the various processor. It also has special accelerators. So you can have accelerators or hardware units which are dedicated, say, for matrix multiplication, something like matrix multiplication, which is a core algorithm for your CNN networks or your deep neural networks, right? So these accelerators, you can have hardware accelerators which can do this job, right? It also enables parallel processing of diverse application, and so the most important thing for autonomous vehicle is the power and performance, right? When you talk about DSP, it takes very less power as compared to a CPU and GPU. So DSP is a must feature in a heterogeneous computing platform. Today, Qualcomm in the Snapdragon Ride platform has a combination of these various processors, and you can use the Snapdragon platform for your automated driving stack. So this is called as a software stack. We have these various processors, and you can use them for developing your automated driving applications, right? So with this, the core topic that I wanted to cover from ADAS and autonomous driving is done. I'll just take few slides on what we are doing on the Qualcomm side to in the automotive domain, right? So Qualcomm, as I was mentioning about the RIDE platform, we are working in this area for the ADAS, in the ADAS domain. So whether it is ADAS applications like tracking or object detection or face detections. We also do AI ML onboarding of these algorithms on the hardware, right? Sorry. Along with that, there's something called as cockpit or IVI, or what you call as the telematics, where, or the instrument clusters, where um, you can have the cameras, displays, audio, multimedia. So you have the cockpit platform along with the ride platform. And the third is connectivity. So as I mentioned, Qualcomm is pioneer in the 5G network. With the ride platform and the cockpit platform, what is growing is the cloud connectivity. Now, as we said, that most of these algorithms are very intense, and running these algorithms only on the board can be possible for safety critical system, but there are certain systems which are not very safety critical. And what you can do is, with the 5G network, you can run them on the edge or you can run them on the cloud. And if you have a 5G network enabled on the on your system, you can offload some of the task to a server and then fetch the information back, right? So we all know about cloud connectivity, but today what is growing is the edge connectivity. So tomorrow, if you have, say, a charging station, I can also take that charging station for edge inferencing. That means I can run edge related algorithms on those infrastructure and use it for fetching it back to the vehicle. So that is one of the use case which comes. So edge, we all use it in an industrial environment, but with an automotive environment, that is some of the these are use cases which are going to grow, right? So with this, so this is about the automotive segment, and what we call this together is the chassis system. So Qualcomm provides opportunity for both cockpit, ride platform, and connectivity, right? So Qualcomm is into this market right from 2002, right? So almost 20 years of experience. It started with telematic solution, and now with Arriver, we are into the ADAS solutions as well. So that's all from my side. So this is my last slide. Any questions? I'm open to questions. I hope the time is there.
To start with, Smita, I have a basic question. So we were talking about a lot of sensor fusion technologies to enable us for a hassle-free commute as well as for a safety travel. So how do you think we can move to level 4 or level 5 in Indian roads? And what are the challenges that we might face when implementing?
Yeah, so today when we talk about Indian roads, we are talking about level 1, level 2, right? And beyond that, when you talk about level 4 or level 5, it is not only from the vehicle manufacturing. There has to be legislation which has to come into place. There has to be infrastructure which has to be coming into place. Without legislation and the infrastructure, this is going to take a long time, because safety is the most crucial thing. If as I mentioned, beyond level 3 or level 4, it is the driver is not responsible. It is the OEM who is responsible, or the tier ones who is responsible when it comes beyond level 3. So in that case, you need to have a proper set of guidelines which has to be written, like in case of accidents, what is going to happen. Second thing, as I was talking about the testing of these systems, sort of, or the safety of intended functions, this is a major area. It is just evolving, and there's a lot of opportunity on testing these vehicles. For testing itself, we are going to have AI ML algorithms for testing such a highly automated vehicle. So given these challenges, I feel, at least in India, it's going to take a long time. All right. but and even globally, it's not easy because um, to bring into a vehicle where safety is so crucial.
True. That's true, Smita. Thank you. And I have another question for the participant from Manikandan sir. Can you share India-specific trials or technologies under development? And how soon do you see level 4 or 5 happening in India? Again, from the same aspects. What are the technologies that are under development when it comes to India?
So under development, if you look at our OEMs today, we are developing most of the systems. So when it comes to ADAS, we have most of the features which are enabled. But still, the driver is in control is the most important underlining condition that we have to, or the rule that we have to follow. So we have tested, I mean, from the adaptive cruise control, we have driver monitoring system. Driving monitoring system, it's not only the driver eyelid monitoring, we are also looking at the, the facial recognition. What are the mood swings? Based on that, we are there are systems which are also identifying how the, the environment inside the car should be based on the driver mood, right? So those are one area which is they are exploring. Second is you have the cruise control or the lane keep assist system. There's something called as free um, I'm sorry, it's called as the free pathway. That means if instead of identifying the vehicles on the road, you identify what is a free space available on the road. So that is another system. In when you come to the parking system, you have completely automated parking assist systems. That is also, you have parking systems are there, but automated parking system is something which they are exploring and trying to find out what can be done here. So these are few of the systems, but so the complexity of the system as you go changes with the environment. The algorithms, the naming would be same. So you have adaptive cruise control on the highway, but if I want to take this adaptive cruise control on the what do you say, on the main roads or on the traffic roads, how do I change it? So then you have the environment which is changing. So the complexity changes with the environment. And tomorrow, if you want to take it on, say, a terrain road where there is a lot of trees, a lot of windings, then, I mean, as the environment changes, the algorithms are also developing. Does that answer the question?
Yes, and
Yeah.
regarding the same. Yes.
Thank you.
Thank you,
Yeah.
ma'am. If autonomous driving is the way forward, are tech companies looking at steering-free cars? Complete autonomous without steering?
Yeah, autonomous is without steering. So it would be like you have an app which calls a vehicle, it comes to you. It, I mean, you can just scan your code and you can just get into the vehicle. It drives you to wherever you want. There's no driver. That's autonomous cars, right? But whether we are able to reach, so in a very closed environment, I would say tomorrow smart cities where you have limited very you have all the traffic sign recognition, you have all the markings on the road. In those scenarios, autonomous cars would work. There are areas globally where they are using autonomous cars. In India, definitely it will come, but there's still a long way we have to go. And we ourselves have to change. We have to follow traffic rules. So these are a couple of challenges.
Hello.
Yeah, Shikalai, sorry, can you hear me?
Yeah, now you're audible. I think that
Okay.
answered Mani's question. Any other questions from the audience?
Okay, I see Ganesh is already working on vehicle to grid system. That's interesting.
Yeah. Good evening. I'm Ganesh from Chennai, actually.
Yeah, hi
We are
Ganesh.
working. Yeah, hi. We are working about this, as you told, this vehicle to grid system. We
Okay.
have some other different methods. Would you like to further with us as a startup? We have registered startup actually. We are designing something.
Sorry, Ganesh, at the last I couldn't hear you.
Would you like to share further with us, or could we further with you in this regard of in this segment of this EV? We are registered startup here. Yeah.
Okay. So
For
just
the
to understand, yeah. So to understand your question, you said you have a product which does vehicle to grid and you want to collaborate in this area
yeah,
or
yeah, in this area.
okay.
Let me just add this here. First off, it's
Yeah, I
fantastic
think
that you
Henry yeah.
let me take this one. So first off, it's fantastic that you have a wonderful startup, and I think it's quite inspiring.
Sir, your
Obviously, I
voice
mean,
is breaking.
yeah, okay,
Henry,
just
your
let me know.
voice is breaking. Sorry.
Okay, let me know if it's still bad. Yeah. If not, I'll just type it on the chat. I think that the best way is, why don't you contact us offline, so then we can go over a little bit more details on your startup. We have a B2B, like specific area of our EV community, specifically focusing on businesses like yours. So we'll be happy to, figure out what's the right ecosystem where we can support or so. Yeah. So this would be great. Yeah. Feel free to contact us to Siki.
Okay, sir. Thank you. Thank you, ma'am.
Yeah, thanks, Henry. Yeah. Thank you, Ganesh. Any other queries? If not, I mean, if you guys have any other queries, please feel free to reach out to Siki committee, to Kritika directly. She will be able to connect you with Smita for further clarifications and further collaborations. Thank you, Smita, for a wonderful session. Yes, Kritika, you wanted to say something?
Okay, thank you. I think then we will conclude the session. Thanks to everyone who has also participated. If you guys also as students, if you have any queries, we are here to. The biggest motivation for us is to actually support our future generations. So if you have any questions, feel free to reach out to us through LinkedIn, Helsinki, however you like, and we'll do our best to support you guys. And especially if you have questions about careers or what kind of future job aspects or where are the industry or information that you can look at. We'll do our best to support you guys. Yeah. So feel free to reach out to us and have a nice rest of the weekend.
Yes, sure, Henry. So can we conclude the call?
Yes, please.
If
Yeah.
the, yeah. Thank you, everybody, for joining the session. Thank you all.